Here we're told to eliminate the parameter t, to rewrite the system of parametric equations below, in other words, this thing, to rewrite that as a Cartesian equation. Now, if you're getting hung up on what a Cartesian equation is, that's just, something like y equals x squared plus blah, 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 right? It's some equation that has y and x in it. And I don't care if y is on the left or x is on the left or whatever. We just need to eliminate the parameter t. So the way you do that, if you remember how to solve systems of equations, is let's work with this easy one. I'm going to rewrite this as, excuse me, messed up already. I'm going to say, let's subtract 5 from each side. And y minus 5 equals 2t. Okay, no one's going to argue with that. And then what if we do this? What if we say, okay, divide each side by 2. So 1/2 times y minus 5 equals t. Well, that's what t is. And if I want, at this point, I can now take that value for t, which I've isolated, and send that back into this guy. So what's that going to turn into? Well, that means x equals 4 times, 1/2 y minus 5 cubed, because that was a t cubed, minus 1. And in this problem, it says simplification is not required, because I don't really want you wasting your time foiling that all out, right? That's going to take you 10 minutes to do, but it wouldn't be that bad. Anyway, this would be the answer, right? It's some equation of x in terms of y. That's called eliminating the parameter t. See, there's no more t's anywhere in here. Goal achieved. Now, you have to be careful with this. You can't just do it willy-nilly. If you look at this one, see, in this last equation, I could have gotten t by itself using the y equation or using the x equation, and then substituting one into the other. It wouldn't matter. But in this one, it does matter. And if you're getting it wrong and you don't know why, well, maybe this is what's going on. Let's just take a look at this. If you were to work with this equation, I'm going to show you the wrong way first. So let's focus on this. If I were to say, okay, x equals negative e to the 4t, let's isolate t in this equation. I would go, okay, fine. First, we isolate the exponential. It's the best I can do at the moment. And then I take the natural log of both sides. So the natural log of negative x equals 4t. And that means t equals 1/4 times the natural log of negative x. And some people get a little worried about this point because they say, oh, I'm not supposed to have a negative sign inside the logarithm. And there it is, right? Big old mean negative right there. Well, it's actually not a problem to have a negative x in the logarithm because x itself could be negative, right? If this were negative 2, that would be natural log of 2, and that would be fine. The problem comes in this. This is going to have domain restrictions. So that caution about don't have negatives inside the logarithm, that's actually a pretty good thing to keep in mind. If you isolate t this way, you're going to get restrictions that were not intended to be there. So we're not going to do it this way. Instead, we're going to isolate t using the y equation. Y equals negative 5 plus 6t. So I'm going to isolate t and say, okay, that means y plus 5 equals 6t, and that means y plus 5 divided by 6 equals t. And now I'm going to take that and plug it into the other equation. So I get this. X equals negative e to the power of 4 times y plus 5 over 6. Looks kind of hilariously gross, right? But, that's what it is. And we have here an equation with both x and y in it. So that's what I call Cartesian, and we are done with this thing. And notice there's no domain restrictions either. Exponents can be anything, negative, positive, it doesn't matter. So I haven't introduced any new domain restrictions that shouldn't have been there. That's really the point of this hint right here.